Okay, now we turn to quadric surface defined by this equation. Okay, so if we have this quadric surface, we want to picture this quadric surface in the xy plane. Well, the xy plane is defined by z equals 0, so we get z equals 0. What's left is x squared over 16 minus y squared over 4 equals 1. And this is a hyperbola that you can easily sketch. Now, I haven't sketched the details, but this is x squared over a squared minus y squared over b squared equals 1. A would be 4, b would be 2. Square root of this, square root of this, so that this, half side of the rectangle, from here to here, is 4, and this rectangle, this distance is 2, which means that the width of the rectangle, or the length of the rectangle, is 8, the width is 4, the vertices are at 4, 0, and negative 4, 0. I've labeled the 4, 0 here. Okay, now if we move up to the plane where z equals 1, then z has to be 1. This term is going to be 1 over 25, so we see that here. Well, we add the 1/25 to both sides, we get 26/25 over here. Now this is not in the standard form of the equation of an ellipse, but we get that form if we divide both sides by 26/25. So we get x squared over 26/25 of 16, y squared over 26/25 of 4. Okay, now we then can take the square root of this, take the square root of this. 26/25 is 4% bigger than 1. So this will be 4% bigger than 16. If we take the square root, what we get will be very close to 2% more than 4. And similarly over here, what we get when we take the square root will be a little more than, will be very close to 2% more than 2. So we're going to get something that looks almost identical to this, but these sides are just 2% bigger. So instead of 4, 2% more than 4 would be 4.08. This would be close to 4.08, and this would be close to negative 4.08. The slopes of these lines would be identical, and you can think about why that's so. But if we increase the x-coordinate of this point by 2% and increase the y-coordinate by 2%, you should be able to conclude very easily that the slope is going to be identical. Okay, and you might think through that if it's not obvious to you. Now, moving to the plane z equals 1, nothing changed by much. That's because 1 over 25 is a small number compared to 1. Okay, let's move to a plane that's a little further up. Let's move to the plane where z equals 4. So in the plane z equals 4, what happens? Now, I didn't write out all the details. You should be able to work them through. They're the same as the details of this, just with different numbers. But if z is 4, we're going to get 4 over 25. And when we add 16 over, it's 4 squared over 25, 16 over 25. And we're going to then add that 16 over 25 to the 1. That's going to give us, if I did my arithmetic right, 41 over 25. Then we're going to have to divide both sides by 41 over 25 to get this number back to 1, to put the thing in standard form. And when we do, this is the equation that we're going to get. And now we've increased the squared value of a, and remember the value of a is what determines the distance from here to here. We've increased that by about 60%. Okay, so we're going to be increasing the square root of this denominator by something between 20 and 30%. So this is going to get not drastically bigger, but it's going to get significantly bigger. I think it ends up around 4.8, and that's actually an underestimate. It's probably going to be closer to 5.1, So I didn't make a very good estimate there, but I wasn't thinking very hard. Okay, so whatever this is going to be, this rectangle is going to be significantly bigger than this one. Meaning that as we move from the xy plane up to the plane z equals 4, the hyperbola that we get, if this is the x direction, the hyperbola that we get is opening in this direction. If this is the xy plane, we get a hyperbola here. If we move up to z equals 4, the hyperbola moves back a little bit that way, and it's out here. Now, it's difficult to see that from the hand waving, so we're going to try to sketch it. And we spent a fair amount of time developing this sketch. And I might, if time permits, do another video where I actually construct this sketch. But what we did was we started with this rectangle, and we drew that in 3 dimensions. Here we've got our x, y, and z axes. So I went out 1, 2, 3, 4 units on the x-axis, and I drew a dotted line here. And then I went out 1, 2 units on the y-axis, and I drew a dotted line here. And then I drew dotted lines here and here to complete the picture of this rectangle. Now, in sketching this, remember that these long sides are parallel to the x-axis. Well, if this is the x-axis, then these sides have to be drawn parallel to that axis. Okay? And these sides are parallel to the y-axis, so we have to draw these sides parallel to the y-axis. The graph has to go through the point 0, 4, or the rectangle goes through the point 0, 4. The graph also does. The rectangle goes through the graph 0, negative 4. The rectangle goes through the point 0, 2, and I'm sorry. Let me back up. I said 0, 4. This point is 4, 0. This point is negative 4, 0. Okay, I said 0, 4, and 0, negative 4, I think. So we have to go through these points, 4, 0, and negative 4, 0. In the xy plane, not including z. And in the xy plane, we also go through the point 0, 2 and the point 0, negative 2. So this is the rectangle that goes through those points. Now, having drawn that rectangle, I draw these dotted lines here, these white dotted lines, one here and one here, and you can see that these lines go through the diagonally 3/4 of the rectangle. So these white lines here correspond to the white lines here, which are asymptotes to the hyperbola. Now, we then note that the hyperbola goes through 4, 0, so here's our point 4, 0 in the xy plane, and we draw a hyperbola so that the axes, so that the hyperbola becomes asymptotic to these diagonal lines. Okay, and we draw that carefully. We just fill this in, and we do the same thing over here at negative 4, 0. Here are the asymptotes, here and here. We draw it like this, and we understand now that this white hyperbola is in the xy plane. Now I'm going to continue, but we're going to then continue. Well, we then continue to do the same thing, but 4 units higher in the plane z equals 4. And then we do a little bit more, and we see what we've got.